Now let's see the first type of graphical representation of the data, that is bar graph. Bar graph of the session. So let's see how a bar graph is understood in statistical means. For example, I take the graph of math marks and number of students. So for example, I have the marks on x-axis and number of students on this, where they are listed through this graph. It generally has bars in this form, and the bars make us understand that the number of students who got marks between 40 and 50 are 20. So here I can convert this into a frequency table by using the bar graph. So before understanding the bar graph, let's try to convert this bar graph into a frequency table. So in this case, I have math marks and the frequency, which is number of students who got those math marks. Now I have this classified into 40 to 50, 50 to 60, I have the graph which shows between 40 to 50 and 60 to 70, and then 80 to 90 and 100 to 110. So for example, this is an example graph which I understand through the frequency table. So the number of students who got marks between 40 and 50 is an elevated bar which reaches up to the value 20. That means there are 20 students who got marks between 40 to 50. The 60 to 70 gets elevated up to 5. So I see the tip of the bar touching the value on y-axis, which gives me the number of students being 5. Next, 80 to 90 touches at 30. I understand this touching at 30. So there are 30 students who got between 80 and 90. And 100 to 110, I see this touching up to 15. So I have 15 students who got the marks between 100 and 110. So class interval and frequency is understood through the bar graph. The size of the bar gives me the class interval, and the tip of the bar touching the y-axis gives me the number of students. Is how we understand the bar graph, helping me in deriving a construction of frequency table. Bar graph helps me in analyzing the data in graphical representation. Now that we have discussed about the first graphical representation, let's get into histograms, which is the second graphical representation. Bar graphs followed with histograms. Now imagine I take the example of a teacher trying to collect the physical education teacher trying to collect the students' weights, and that purely comes in with histogram. Let's see how a histogram helps me in classifying the data. For example, I have weights of students in kilogram, and my y-axis is number of students. Then let's say the graph which gives me out here. In a class of 25 students, I want to take the weights of students in kilograms on the x-axis in such a manner that I start from 35, 45, 85. Say for example, this is my weights in kilograms and this is number of students. Let's try to convert this into a frequency table and understand how an histogram helps me in analyzing the frequency table and the data itself. So when I take this into the tabular form, I clearly see weights in kilograms and number of students falling in that range. I clearly see that 35 to 45 kg range gives me 5 students who lie in this range. So the students who weigh between 35 to 45, there are 5 students lying between that weight. 45 to 55, there are 15 students. Who lie in this range. 55 to 65, there are 10 students who lie in this range. Then 65 to 75, they lie in the range of 25. And 75 to 85, there are only 2 students. If I approximately take here, I see that 75 to 85, the frequency is 2. So the given histogram, when converted to the frequency table, I clearly understand that the students who have their weights in group data have their frequency picked from the tip of the bar and then with the value on the y-axis. This is 5, this is 10, this is 15, this is 25. That's how I get the frequency, which in turn makes me understand in real life situation that there are 5 students who lie between 35 to 45 kgs. There are 15 students who lie between 45 to 55 kgs, etc. Histogram connected with a frequency table. It is very important to note when we take the first graphical representation, that is the bar graph, connected with the second representation, histogram. What is the difference between a bar graph and a histogram? Let's see the note. Histogram has all the bars connected continuously. without any gaps, unlike the bar graphs. It's very important to note that in bar graphs we had gaps in between, but when we take the histogram, there is no gap, but they are continuously developed until the last. So the one major difference is that histogram has all the bars connected continuously without any gaps, unlike the bar graphs. Is how we differentiate between a bar graph and a histogram. Now that we have discussed about histogram, one of the most important concepts we are going to discuss in histogram is length of the rectangle. So let's see how an histogram is related with length of the rectangle. This session is about length of the rectangle for a histogram. As we have discussed about an histogram, it generally has all the rectangular bars which give thing. Now how do we calculate the length of each of the rectangle? This, and this. So this session is about finding the length of the rectangle given the frequency and the class interval and the class width. So here we have a formula which says length of the rectangle bar of that specific bar in a histogram. Length of the rectangular bar in a histogram is given by frequency by class width into minimum class width is how we have the formula which we're going to use in finding the length of the rectangular bar, given by the formula frequency by class width into minimum class width. Let's take an example problem to calculate the length of rectangle bars of each of the class interval. Now here is an example problem for which I would like to find the length of each rectangular bar represented by each class interval. So let's see how we can find the length of the rectangular bar. Now clearly I see that for finding the length of the rectangular bar in the histogram, I need the frequency which is already given, but I need the class width and the minimum class width. So let's see what is the class width and the minimum class width. So here I have class width. I clearly see that the class width out here is 0 to 20. So the width of the class is 20. Upper limit minus lower limit, 20 minus 0 is 20. And here the upper limit is 30 and the lower limit is 20. So 30 minus 20 is 10. So the class width of the second class interval is 10. Here the upper limit is 40 and the lower limit is 30. So 40 minus 30 is 10. So the length of this class is 10. Similarly 50 minus 40 is 10. And 80 minus 50 is 30. Is how we get the class widths of each of the class intervals. Now clearly I see that the minimum class width is the least of all these values, and I clearly see that 10 is the least of all the class. So minimum class width is 10. Now we have the minimum class width, we have the class width, and we have the frequency. Therefore, the length of the rectangle is given by the formula frequency by class width into minimum class width. So here, frequency by class width into minimum class width is what we get. Proceeding out here, 7 by 2 is 3.5. So length of the rectangle for the first class interval is 3.5. Similarly, here frequency by class width into minimum is 10. And thirdly, the frequency by minimum by class width to this is 10. And here the frequency is 20. And then finally the frequency by 30 into the class width into minimum class width is 10, which is this. Therefore, the length of the rectangle for each of the class intervals is 3.5 for this class interval, 10 for this, 10 for this, 20 for this, and 10 for this. Is how we understand the length of the rectangle connected with respective class intervals. Now that we have discussed the two graphical representations, now comes the third and the final graphical representation of data called the frequency polygon. What is a frequency polygon? We know that a polygon is an n-sided closed figure. So a frequency table also defines an n-sided closed figure using the histogram, and that n-sided closed figure is called polygon of n sides. So let's see a polygon in brief. Let's take a histogram for example. For example, I have a histogram with all marks of students. Let's say this is the polygon. Now here I have the marks obtained. So here I have a histogram. So let's see how we can understand a frequency polygon for this, where this represents marks of students, map marks of students, and number of students. So the students who got the marks between 40 and 50 is 10, is how we understand the frequency table. And who got 50 to 60 is 20, and 60 to 70 is 10, 70 to 80 is 30, 80 to 90 is 5, 90 to 100 is 10, is how we understand this histogram. So frequency polygon is obtained when I join all the midpoints of the width of the histogram. So I pick all the midpoints here, here, here. So a polygon is obtained if I take exactly a line passing through the middle and cutting here. and here exactly cutting at middle point, we get a polygon. So a polygon which is A, B, C, D, E, F, G and H is called a frequency polygon. So here we define in this example problem A, B, C, D, E, F, G, H is called a frequency polygon. A frequency polygon with n sides closed figure. A histogram with all its midpoints joined gives us a frequency polygon. Now that we have understood a frequency polygon through a histogram, now the question comes, what if the histogram is not given? Can we construct a frequency polygon without the help of a histogram? Yes, it's possible, if we can use the formula for class mark. So this session is about constructing a frequency polygon without the help of a histogram. Frequency polygon. Constructing a frequency polygon without its histogram. If the histogram is given, it's very easy because we pick the midpoints of the top bars and just join, and we get an n-sided closed figure called frequency polygon. But if the histogram is not given, it is very difficult to pick the middle points, and hence we have some other method which we use out here. So let's see how we can construct a frequency polygon for a given data without the construction of the histogram. For example, I have the data with class interval and frequency. So in this case, say my class interval is the marks of range 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 90 to 100. And say the frequency is 7, 3, 4, 5, 8, 2. 8, 2. So here is the frequency through which I'm going to construct the new column called class marks. Class marks will help me in constructing a frequency polygon without the help of a histogram. What is a class mark? The class mark is nothing but the upper limit plus lower limit by 2. That's how we use the formula. So the formula for class mark is upper limit plus lower limit by 2. If I take the first class interval, this is upper limit and this is lower limit. So upper limit plus lower limit by 2, which gives me 55. The class mark for this class interval is 45, and the class mark for this class interval is upper limit plus lower limit by 2, which is 55, 65, 75, 85, and 95 is how I get the class marks, upper limit plus lower limit by 2. Once we get the class marks, then I pick the points and plot. So here I have the point with 45 and 7. My x coordinate is 45 and my y coordinate is 7. In the second case, my x coordinate is 55 and y coordinate is 3, 65, 4, 75, 9. So once I get the coordinates, it's all about plotting on the graph paper. So I pick the marks 50, 60, 70, 80, 100, 6, 8, 10. So the first point is 45, 7. So it lies 45 and approximately out here. Next 55 and 3, which lies 55. This. Next is 65, 4, which lies somewhere here. Then 75 and 9. 75 is here and it shoots up to 9 out here. And then I have 85 and 8, which comes 85, approximately down, and 95 and 2. So finally 95 here and 2. Now it's about continuously trying to join each of the points. So I start from the least value, which is out here. So somewhere out here I have 35, which I pick and join. I get a polygon, which is called a frequency polygon. A, B, C, D, E, F, G, H is a polygon which is a frequency polygon given by this region. Frequency polygon constructed without the help of histogram using the class marks. Class mark equals upper limit plus lower limit by 2. Construction of frequency polygon. Now that we have discussed certain properties in statistics, now comes the most important concepts in statistics: measures of central tendency. As the word speaks about measures of central tendency, what do we mean by measures of central tendency, or what is its significance in the branch of statistics? As it says, measures of central tendency. Now imagine I have the collection of 200 data. Now in that 200 data which I have collected personally, I want to know how I can find the relation between each data. There might be definitely some core data which can make us have the tendency of depending on the entire data. So here we are going to see that central value upon which the rest of the data relies or depends on. So such things in mathematics are studied through measures of central tendency. There are 3 measures of central tendency identified in the branch of statistics. One is mean, median, and the third is mode. So these are the 3 different types of measures of central tendency identified. Let's discuss these in brief. So let's take a note that the 3 measures of central tendency are assumed to study and analyze the entire data based on their values. The three measures of central tendency are assumed to study and analyze the entire data based on their values. So this is one of the significance of measures of central tendency. Let's see in brief mean, median, and mode.